Good morning. Glad to be here. My name is Paul Riccomini, and I am a professor at Clemson University, and I'm very excited to be here to have the opportunity to talk about math instruction, especially math instruction for kids that are struggling with learning math, which all of you, I'm sure, have experienced at great length. And it's something that this country is really trying to step up to the plate, kind of like what's happened in the reading field. We're now trying to get a hold of math, and math teachers are finally saying, thank goodness. Now you realize we're in the minority. The rest of the country is still going, why did they put letters into math? But to give you a little background about myself, I am at Clemson University. That is in the ACC. Please do not hold that against me here in Georgia Bulldog country. But I have been at Clemson for 7 years, and I am in the School of Education department, specifically in the Special Education department. And my main focus is working with kids with learning disabilities, targeting math. And that's what I really enjoy doing. And along the lines of targeting kids with learning disabilities, I've also targeted kids that are at risk. And what you see are a lot of similarities. Now, sort of to get a feel who I have here, how many of you are middle school math teachers? Raise your hand. Oh my goodness. All right. How about high school math teachers? All right, so we're predominantly, the majority are middle school. Good. I taught 7th and 8th grade for a couple of years, and that was definitely my most favorite year. Now, how many of you are special education teachers? All right. Now, let me ask this again, and everyone needs to raise their hand. How many of you are special education teachers? We all are, okay? Kids with learning disabilities are absolutely required to learn the standards. Therefore, they are in the regular ed classroom, all right? So we are all working with kids that struggle with math. But just background about myself. Prior to going back to graduate school, when I was an undergraduate, I actually was a math major. I had aspirations of becoming an actuarial scientist. And then I did a little bit of an internship and realized sitting in a cubicle, as much as I liked math, working on a calculator really wasn't for me. So then I got into secondary mathematics, and I started to do that. My father was a school psychologist and a special education professor. He said, why don't you take some special ed classes? And as good children do to their parents who are paying their tuition, I took those classes. So when I finished, I had a math degree. I was certified to teach secondary math and special education. Little did I know that would make me today a highly qualified secondary special education teacher for teaching math. So my background has always been revolving around math. And when I went into the public school system to work, as soon as they realized that I was a math teacher, I taught math at every grade level, whether it was special ed or regular ed. And I started in middle school, and then I moved up to self-contained high school math, where I had kids that barely could do their multiplication facts, hated algebra, hated math, all the motivation issues that go along with that. And then I ended up getting into pre-calculus, calculus, trig at the high school level. And then my last year, I taught at a gifted and talented magnet school in North Carolina, 8th graders. And just to give you a little context, these kids were scoring 1,400 on their SATs, which they started taking in 5th grade. So I've had the whole wide range of experiences with kids that could barely do basic math to kids that were really ready to take off. So the thing that I've sort of taken across all of them is that you have the same issues with all of the kids. There's motivational issues. The gifted kids don't do their homework either, just like the regular LD kids, or if they do it, they're doing it on the bus. They can't find their homework. All right, they have problems across the board, and they're similar. Now we have them all in our classes, and we need to meet these high standards, and the big, buzzword is proficiency. And that's what we're sort of striving to. So today, sort of to give you an outline of sort of what we're going to do, that was the introduction. Now you all know who I am. Then we're going to talk briefly about the National Mathematics Panel Advisory Report. And I just want to hit on a couple of things. with that report that will sort of set the table for what I'm going to do for the remainder of the day. Then we're going to talk about math. Now, this workshop is about how you teach math, not about content. You're not going to leave here knowing more about math, but I will have you do some math, and we'll see how many of us struggle in here as well. And then we're going to talk about this effective instruction, this buzzword that we're starting to hear, and how this sort of translates into the classroom and what you're doing on a day-to-day basis. And then we're going to get into some other techniques, and depending how the time goes, I'm going to talk a little bit about math vocabulary at the end. But that's sort of how the day is going to go. Please feel free to ask questions, share experiences, and so forth. One of the things that I have really started to recognize is that the problems and the challenges that you're dealing with here in Georgia are really no different than the problems other states are dealing with. You've got kids that struggle in math, and it's something that we all need to work together. Your best resources and assets are the people sitting right beside you and networking and so forth. So hopefully we'll have some time to share. The first thing I want to do in your handout that looks like this, which is not the PowerPoints, we're going to take about 3 to 4 minutes. I saw some of you working ahead. I already know where the gifted kids are here in this session, or at least the ones that want to try to get ahead so they appear to be gifted. What I want you to do is just briefly discuss some of the challenges that you're dealing with right now. You've been in school for about a month, right, in Georgia, about a month, and it related to math, and specifically the instruction, Georgia state standards, which have been recently revised and being slowly implemented. Any of the assessments, every state has a high stakes assessment at the end of the year. That's sort of that's why we teach, right? Do you get a 4 on that end of grade test, right? That's right. But anyway, I would like you to come up with, boil it down to a top 4 list. Keep in mind, at-risk kids, kids who struggle in math. And by the way, everyone struggles in math at some point. All right, so go ahead and take a couple of minutes to do this. I'll circulate around and see if I can share in any of the discussions. Go ahead. Okay, and just sort of bring it to a close. Very, very good discussion, and I will just say that in the course of 5 minutes, we were able to basically you were able to basically come up with the major issues that the National Mathematics Advisory Panel came up in across about 2 or 3 years. And we spent a lot less money on that, all right? And as I walk around, everyone is basically saying the same things, okay? So that's a good thing. We're having the same problems, which means as a state, as a department, we need to work together. So who would like to share their number 1 issue that was discussed at their table? Table number 6.
We say a lack of foundation / building blocks.
Lack of foundation of math, building blocks. Sometimes that's referred to as number sense. I don't know. How many of you had lack of foundation? Good. A lot of us had that. Lack of foundation. That's definitely a major issue. So since we are middle school and high school teachers in here, we can blame whom? The elementary teachers, right? Now remember, when I work with elementary teachers, who do they blame? Parents. When I work with high school teachers, they blame middle school. And who do my colleagues blame? High school teachers. So it's the whole gamut's in there. All right, so we got poor foundational skills. Table 7.
Vocabulary, particularly for my English as a second language students.
ESL students. How many of you are dealing with sort of that population of students? Vocabulary is huge in math. Math in and by itself is a very technical language. And as I had discussed with her earlier, math vocabulary, except for our kids, is only discussed during math class. Now, with your own personal children at the table, I'm sure you talk about minuend and subtrahend, right? And the Pythagorean theorem. But the only time they hear it is during math class. And the other problem with that is that we all default to an informal language. And we can go back and forth, no problem. However, our kids, they get very confused. And then we're talking about kids with learning disabilities. They already have a poor vocabulary. In general, math is even smaller. And if you cannot understand the language of instruction, then you cannot learn what you're doing. And if you think about it, if I were up here talking about a high-level nanotechnology type of device, which, by the way, I couldn't. You're all very intelligent, but you would not have the vocabulary to really have a good understanding. And now I'm going to go ahead and go to table number 9, because this is related to what table number 7 said, and that was reading. And go ahead and say what you said about reading.
We had vocabulary and reading comprehension deficits.
Reading is a big issue, all right? There's a reason why reading is the major focus in schools. The number one way that kids are identified or referred for learning disability is reading. That's the number one reason. And reading crosses all of the curriculum areas, and that's something that is a major issue as well, is reading in math. And that's something that we have to work with. Our reading, you know, we have reading across the curriculum, writing across the curriculum. When are we going to have math across the curriculum? I mean, come on. But yeah, reading. So we've got poor foundation. We have vocabulary connected with reading is another. All right, what's some other things? Table number 2.
Low processing skills?
Low processing skills.
Meaning that they don't comprehend. They can read it off the paper, but they aren't comprehending
why you're doing it. Or I think sort of what she's really getting at is the application, all right? Sort of if you do a math problem and it's just numbers, I call that naked problems. And it really doesn't mean anything until we put it into the application stage. And kids have a hard time seeing the application. Actually, a lot of adults in the United States don't see that much of what they do on a day-to-day basis is founded in math. All right, now we've been working these tables up here. How about there in the back? Table 14. Do you have anything that we haven't talked about yet?
Well, we said word problems, and I think that's connected to the application.
Yeah. Word problems in math is code for basically problem solving. That's how we try to get at it. And there you're going to have reading enter into it, you're going to have vocabulary, and when kids see a word problem, well, what are they going to do? That's right. What if I were to put up a word problem right now? A train leaves Atlanta, heading south. And we're all math teachers, and we're going, oh, gosh, please don't. Is this going to be on camera? I got to edit it. I mean, it's that whole, genre that we have of math problems. Word problems is how we sort of try to get at problem solving. And, yeah, that's definitely an issue. Good. Table 8.
I think it's too many standards in too little time.
Yes. That is definitely one of the major findings in the National Math Panel report, is that in this country, not specific to Georgia, but in this country, we tend, especially at the elementary grade levels, try to teach far too many math concepts in the course of the year. And a lot of times what happens is kids are not really learning anything deep. And that's where you get mile long and an inch deep. So yeah, I think that is something. In the United States, a lot of curriculum cover as many as 20, 25 big ideas in math at elementary grade levels, when other countries are doing 6 or 7. And that doesn't mean they're done teaching math by October. What that means is the kids really get into the conceptual, the procedural, the computation. They have the time to really expand. That's probably sort of my take of why we do poorly at 8th grade and at high school, because elementary school, we tend to do okay in comparison, but as soon as math starts to get much more complex, we sort of fall off the chart. And I think that's one reason we have far too many things to teach. Now, that's changing. The dialogue is happening. Go ahead, table 1.
We said content versus representation. Sometimes when you're grading, just because the answer is correct, sometimes if they make a mistake, it could just be the representation. Did they just make an error in the representation? But then some students, if you look at their wrong answer, it will actually be the content. They didn't understand, and that's how they received the wrong answer.
That's right. Math is, whether you sort of, whatever your take is on math, math is a logical progression of rules, theorems, laws, procedures that explain all concepts. And you can actually work through, get the right answer, but completely misinterpret what it is you're trying to do and end up getting the right answer. Something else that sort of no one's really brought up, maybe we're afraid. Go ahead, table 3.
We've noticed that our students sometimes arrive with a preconceived notion about math, meaning that they enter the classroom saying, I can't do this.
Motivation, all right? Attitudes, all right? Did everyone talk about that? And folks, this is a major problem. And the older the kids get, the harder it is. Think about something right now, unrelated to your professional lives, that you absolutely hate to do, all right? That you hate to do. You don't have to share this, all right? Okay? Everyone got something in their head? Everybody's feeling, gosh, Number 1, do you actively seek out to do it? You avoid it at all costs. Absolutely. When you have to do it, and that usually happens, when you have to do it, are you happy? No. Don't talk to me. I have to fill out this report. I have to do this. How does that sort of show in our kids? They don't do their homework. They forget their math book. They forget their pencil. They have to go to the bathroom. They have to go to the bathroom for their friends. I mean, you know, you have all of these issues. They're avoiding it. Why? Because by the time they've gotten to 5th, 6th, 7th grade, they have failed miserably in math, and they hate it. Many of kids with learning disabilities, the entire school process has been unsuccessful. Therefore, as soon as they are able to what? They do. Drop out, they do. It's a big issue, all right? All right, go ahead, table 9.
Misconceptions in math, and there are 2 areas. One where they think they understand the process, like you're multiplying, and they may know that 8 times 7 is 56, but instead of writing the 6 and carrying the 5, they write the 5 and carry the 6. And then the other is things that we use in class sometimes, like when we're teaching the order of operations, we use, please excuse my dear Aunt Sally. Well, that's not technically correct, because at the end, the M and the D stands for whichever comes first, for multiplication and division, and for addition and subtraction as well.
That's right. A lot, you know, with that, please excuse my dear Aunt Sally, that's a first letter mnemonic.
Right.
And in and by itself, it can lead kids to the wrong operation unless the teacher is there saying multiply, divide, left to right. Add, subtract. A lot of students' errors, you know, I hate to say this, are either because of the curriculum or things we've said to kids. Like 0 means nothing, right? No, 0 technically is a placeholder, but a lot of misconceptions kids have, absolutely. Now, the other thing she was getting at was procedures in math. Now, for a long period of time, procedures, computation, was completely de-emphasized. For whatever reason, practice was bad, all right? And some of you, no one said this, maybe they're afraid to say this, but a lot of you wrote down basic facts. We cannot get around that. Basic facts is a problem. You go to any remedial math class, an LD classroom, I would be willing to bet your salary, right here, I'd be willing to bet her salary, that 90% of those kids are not fluent on their facts, all right? In elementary school, you see a lot of this. In middle school, it sort of goes down. In high school, you sort of see this. And then you see them, I don't care, 24, 13, 15, you know, until they guess the answer. Basic facts is a major issue, all right? And it's something that elementary schools are starting to do a decent about it. And my take, and I saw some of this on some of your papers, is we started using calculators far too early to compensate for basic facts. That's something that's starting to change. But that's good. Just one more and then I'll move on. Anybody else have anything that they really want to talk about? Table 3.
I'm a special ed teacher working in a collaborative setting, and I see the lack of adequate teacher delivery in the classroom. Sometimes the teacher knows how to do the problem or how to read it, but when it's delivered, it's not adequate for our students or general.
And that's sort of, I'm glad, I wish I could say I prompted her for that, but that's sort of going to be, that's going to lead into the rest of the day. And that how we teach absolutely affects kids' learning. How we present it, the examples, how we communicate to our kids the content that we want them to learn impacts their learning. Absolutely. Now, of course, free will has to take into place, and you have all these motivation issues on top. But we're going to talk about the report. The instruction that is delivered and the curriculum that is used is absolutely a major impact variable of kids' learning. And sometimes math teachers, why are we all math teachers? And this is something that's very, very important that we must remember. How many of you failed math? How many of you failed math twice? How many of you did not take any math classes in college? Why are we math teachers? We like math. Why do we like math? Because we can do it. All right? Yes, I'm assuming, yes, I just made a large assumption there. Yes. And those of us that struggled in math, we eventually figured it out. And we are working with kids that they've not just struggled that day on that concept in your math class, but they have struggled most likely on everything that came prior to that. So it's something we have to remember. We got it. We're good at it. All right? You ever do some sports activity for the first time with someone that's good at it? Kind of makes you feel inadequate. All right? So, you know, this activity was very important to show that all of you have come from across the various states in Georgia. You're all struggling with the same things. The country is struggling with these same things. We're trying to come to grips to the amount of math content we teach. We're trying to come to grips to how we teach that math. We have motivation. Parental issues is an area as well. So these are all the things that hopefully, first off, disclaimer for today's workshop, I will have no answers to all of those problems, okay? It's going to take a concerted effort of working together, starting at the elementary school and moving all the way up through high school and so forth. All right, good. Now, real quickly, I want to talk about the math panel report. First off, how many have read the report? Okay, homework assignment number 1. You didn't know I was going to assign you homework. You need to read the report, all right? And there's a link on here, and I've given you an executive summary in that one handout. But the National Reading Panel report has come out about 6 years ago, and the math report tried to do the same thing. They reviewed a huge body of research. They talked to a lot of people, a lot of organizations, lots of public meetings, and they interviewed a lot of algebra teachers. How many of you teach Algebra 1 in here, the initial Algebra 1? Any Algebra 1 teachers? Most of that survey, we basically highlighted exactly what was said. Motivation is the largest challenge, too dependent upon calculators, not good in their number sense or their foundation of skills. This report is available at this website, and it's in your packet on one of your slides. You can download it for free or order it, and it'll come to you. I highly recommend that if you teach math, you need to have this on your desk. Basically, when they started looking at proficiency, now proficiency is the key, and we'll talk about how that's defined a little bit later. But, you know, I'm not here to beat up math teachers. We get beat up enough. Educators in general get beat up enough. But when we look across the board internationally, we are not performing at levels of other countries. The biggest issue that they found in the review of the literature is that fractions is the biggest problem in the United States. Fractions. Now, that's a problem because although people think of fractions as a concept in and by itself, fractions is really a major pre-skill to ratios and proportions, which is really how we solve a great number of problems in math. But fractions is the biggest issue. So later on, and when we start talking about what your school's doing, one area that needs to be targeted is fractions. If you have extra time for math, reviewing fractions is a major issue. Now, no one really knows why fractions is an issue. Personally, I think the biggest problem with fractions starts with equivalent, trying to find equivalent fractions. And why is finding equivalent fractions so difficult? Well, most of the time it is they don't know their multiplication facts, and that's a problem. Proficiency at higher grade levels, very few kids are getting to that proficient level at the upper grade levels. And then at colleges, and not just Clemson, even at Georgia, we're seeing a great number of remedial math classes being taught for pre-engineering majors. Now, Clemson has an average SAT of like 1320. The same time our SAT scores are going up, the number of remedial, and that's not a really good word, but the review math classes that colleges are offering is also going up. And they're not reviewing algebra necessarily. They're going down to the basic types of things in mathematics. And then there's achievement gap. And this is where the kids with learning disabilities come into, and not just learning disabilities, but at-risk kids and kids that struggle. There is a gap. That's that gap that everybody talks about trying to close. And it starts in elementary school with meaningful differences, but it continues to get wider and wider and wider. And one of the things that's so different in math is that math really is a content area that you take it until you fail. All right? Most of us made it to the upper levels. But usually you have kids say, okay, I made it through Algebra 1. Boy, I kind of liked it. Then they hit geometry. Now, I realize in Georgia you don't have necessarily Algebra 1, Algebra 2 geometry anymore. But you sort of take geometry, man, I'm not taking any more math. And if they don't have to take any more math, they don't take any more math. It's very different than a lot of other subject areas. Now, within this, task groups, and this is just a nutshell, and I'm going to focus more on instruction, but these were the 5 areas that they looked at. The concept, knowledge, and skills, that's really the content, and the whole focus of this report, now this is debatable in my opinion, is getting kids ready to take algebra. Now that's debatable, why algebra is that important, but algebra is the main focus to get more kids into algebra. And you know, bottom line is algebra is that ticket that's going to get you in later on. Whether you use algebra skills or not, if you can't get through it, you're not going to get access to a good SAT score, you're not going to get access to universities, earning money, and so forth. Algebra is the main push right now. But these are sort of what they looked at, and what I want to focus on, and just real quickly, we're in a day and age that we've not seen in education in a long time, and that is we are really looking at what we do in the classroom. 10 years ago, when I was teaching, you know, one of my evaluations at my high school was, you did an excellent job this year. You only sent 2 kids to the office. Excellent. All right? That's no longer happening. It's more like, you have 3 kids at proficient, 10 kids, and they're looking at the scores. We've changed, and that change has led us to look at how and what we teach. Several years ago, you could do whatever you wanted to do in the classroom. It was about being creative. It was about being that, you know, that teacher. You can still do that, but there's a big but, B-U-T, connected to that. All right? Probably shouldn't actually phrase it like that. But that is, as long as the kids are what? Learning? Yes, I'd like to say it is. As long as they're passing the tests, okay? So we're looking at the research that's behind math interventions. Now, unfortunately, in the area of math, if there's this much for reading, there's about this much for math. It's an area that's slowly developing, but the report really made its recommendations based on high quality research that was done with high quality, with ample number of students across multiple settings. But now, the curricular content, and this directly addresses your comment from Table 8, which is streamlining of the curriculum, all right? The math report, the panel is saying we need to sort of focus down what we're teaching to get kids to be proficient at it. It's almost teach less better so they can learn more in the long run, kind of like the turtle and the rabbit race. We start off as the rabbit, basically, and we all know what happens there. The rabbit gets burnt out, and the turtle that was sort of plugging along ends up winning. We need to do a better job in the elementary and even in the preschool. The report talked about Head Start preschool programs, focusing on math. But there's sort of a streamlining, and now we're hearing another word come up that sort of went away for a while, and that's mastery. All right? Proficiency, mastery, they kind of use interchangeable. Mastery, we went away from mastery, we're sort of proficiency, but mastery basically means the kids are fluent, they are accurate, and it's something they can do without struggling at. Whole numbers, fractions, and geometry and measurement, particularly important for foundations of algebra. And page 22 in the report, avoid any approach that continually revisits topics with closure. Now, I am not an expert on the Georgia Standards, but the Georgia Standards are doing exactly what the report says that they should be doing, and that is there's certain concepts that need to be learned at this grade level, then they move on at the next grade level. Up until recently, we've used what they call spiraling curriculum, where we teach it a little bit, eventually we come back. And then one of the reasons we do that is we teach so much, it's hard to teach mastery. So what they're saying is we need to learn these certain concepts or standards or big ideas, then move forward. Revisiting stuff, what we find is we're not really learning much of anything really well. Now, the learning process. And again, this is trying, I hate to use the term math wars, but we basically went through this series of several years where don't teach facts, teach problem solving, teach facts, teach problem solving, blah, 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 back and forth, makes you dizzy. Simple fact in here is how many of you here don't know your math facts? If I gave you a math worksheet and you had to use calculators, how many of you would have to use a calculator? Nobody, all right? So the report is saying that argument is nonsense. What we need to do is a curriculum that will develop conceptual knowledge, computational fluency, factual knowledge, and problem solving simultaneously. Now, that doesn't mean you teach everything at the exact same time. That means that that's what your goal is across the course of a year. Bottom line is, kids have to understand the concepts, they have to be able to compute it accurately, and they have to be able to apply it. That is proficiency. So in your math programs, and it's all dependent upon grade levels. At elementary school, there's a new focus now on computational fluency as well as conceptual problem solving to get kids moving them forward. Practice. A lot of what I'm going to talk about for the rest of the day sort of goes back to that first psychology class you had in college. Remember that Psych 101? At Clemson, there was probably 50 people in it. At Georgia, there was probably 300. The professor probably never showed up. No. But basically, what we know is we have working memory, short-term memory, and long-term memory. There's only so much that can be processed in working memory. So practice is a way to make things become automatic so they can focus on other things. Now, I'm going to talk a little bit about better ways to do practice. I'm certainly not advocating, and neither was the report advocating for drill and practice or drill and kill. All right? There are good ways to do practice, and there are not so good ways to do practice. And one of the things we have to remember in math, and Cal Ripken Jr. said this, practice does not make perfect. Perfect practice makes perfect. If a kid practices 10 problems and he's doing them all wrong, he's basically learned it the wrong way. And that goes back to your comment over there as well. So we're going to talk about better ways to do practice, but here's the other big thing here. Practice must be combined with instruction. A lot of times we address remedial type of classes or extra math, and I think in Georgia that it's connections. Is that what they call the extra math class? That cannot be all practice. There needs to be a great deal of instruction paired with the practice. And then eventually what we're looking for is this transfer, and some people brought this up, transferring of the math concept skill to solving in the real world. And that's something that, in general, this country does not do very well with adults. Now, practices. This is sort of, there's a huge debate going on, and I'm purposely perfectly willing to have this debate about student-centered, teacher-centered instruction. The report is finally coming out and saying, look, neither one, exclusive use of all student-centered, in other words, it's up to the student to learn, and exclusive use of teacher-directed, the teacher is the main component, neither one is completely supported in the research. That in the content of math, there are certain things that the teacher must teach. There are other things that the students must be able to apply. So neither one is supported exclusively in the research. Now, with that being said, that basically in the next sentence, they talk specifically about low achievers and kids that have learning disabilities. And this is what we're going to really get into next, is the panel specifically recommends that the research is very clear on this. Kids with learning disabilities, at-risk kids, low achievers, all right? So you get the picture of those in your head, that they need explicit methods of instruction available on a regular basis. They also need clear problem-solving models. Guess and check is not a clear problem-solving model. And it's actually named improperly, because when we're saying guessing, we're really talking about estimating. And depending on the problem will determine how you do that estimation or that strategy. But they need very clear problem-solving models. And where does that become a problem? Could someone please tell me the chapter in their math book that teaches problem-solving? What do you mean? That's our main goal. It's not in there? It's embedded throughout. And problem solving is a higher order skill. It requires the blending of infinitely number of intricate minor skills, which include reading, vocabulary, computation, motivation, the whole 9 yards there. Kids need to be directly taught how to do that. Examples. Coming up with good examples is a skill that, you know, there's some math teachers that they just know how to come up with an example that really gets the kids to learn what they're trying to do. Math textbooks, unfortunately, are not the best. All right? They're very unkind to naive learners. So examples and how you approach things are very important. Concrete. Now, middle school and high school teachers, elementary teachers will use manipulatives. Middle school teachers, it kind of varies. High school, that's for kids. But what the panel is saying, that there is something to be said about taking kids from a progression from concrete to sort of picture representations to the abstract. A lot of times what we do is we start with the abstract. You ever have someone explain something to you and say, whoa, wait a second. Show me. You're basically going back down to study the picture or concrete level. And then we need to have as much of this thinking out loud as possible. They need to see why it is you're solving problems certain ways, why it is you're applying that concept versus this one, or this algorithm versus that one. They need to see as much of that as possible. So this is sort of what they've recommended, and that's sort of going to set what we're going to really talk about, because my experience with this explicit methods of instruction, a lot of people sort of default that to, oh, that's just teacher lecture. All right? And that could not be farther from the point. And when someone says teacher lecture, that's what explicit instruction is, they really are showing you they really don't understand what explicit instruction is. It includes both a delivery of the information by the teacher with specific techniques, as well as a design aspect of the examples and how you structure your lesson. That's sort of what we're going to talk about from this point forward. This is what we need to be doing to our kids that struggle to get them to a point of independence. So the report is available right here. If you're not good at remembering websites, Google National Math Panel Report. You can get the full version. You can order it. It comes in a nice blue copy. I couldn't wait to get mine, so I actually printed it and bound it right here. But you need to get this report and look at it. In your handout with the breakout activity, I've given you just sort of a 2-page executive summary of the report. There's a lot of information in this report. But I'm just focusing sort of on the instructional aspect. But on page 2, let's see, on the second, here we go. On the second page, it says effective instruction matters, and I think that's what you were saying up here. How we teach impacts kids. Now, I know sometimes that's difficult. Get out of the mindset of, you know, you learned this last year. I know you did. I'm not going to bother teaching that because we got to move on to this, and this is how you're going to learn it. You know, the buzzword for that is called differentiated instruction. All right, making adjustments to kids and their learning. But this is the report. Those few slides that I showed up there, there's a presentation on there with actually a podcast. You can listen to someone talking over it, but I pulled those slides out. There's a lot of other information in there related to other things. For example, the report recommends that people that teach math should be paid more. That's a good thing, right? Sure, of course it is. But, of course there has to be a but attached to it. Those that teach math well as measured by their students' success. So take a look at it. It's something you have to have. If you're a principal, give him a copy. Tab it out like I have so he knows where to look. Give him the executive summary. This really needs to start driving what we're doing in math class. Now, just to show you some of these things, 2% are getting advanced levels in math. All right? Now, people look at that and go, no way is it 2%. All right? These are kids that are excelling in math. It's just not happening. What we have in this country are a lot of kids that can do okay in math, but they absolutely hate it. And they don't want to take math classes. And then with women, female students, as soon as they can opt out of the advanced or a pre-engineering track, they tend to. Now, I don't know why. When I worked in the gifted class in 8th grade, some of the girls I had, actually the majority of the best were girls. But when I asked them what they were going to do, it was other tracks outside of the STEMs, which is science, technology, math, engineering. Grade 4, I mean, that's a quarter of our students to a third are below basic. That is not LD only. There's a lot of kids in there. Sort of, now where does this become a problem is, well, who struggles in math? Well, basically right now, when I start showing you some larger statistics, the report basically shows, and I don't know why this was something so big, kids come into school with literacy issues, right? Some kids know their names, some kids can write their names, some kids may even be able to read. But there's a huge gap. Well, guess what? They found the same thing in math. Some kids are coming in with significantly developed number sense, while others are not. Learning disabilities, you know, pretty much they struggle with everything. They have poor organization, they can't retrieve information, the whole 9 yards. Give them a calculator, you know, I'm a firm believer in the use of calculators. But one story that really was a V8 moment, you ever have a V8 moment like that? I taught a lesson in high school, gave the calculators, a young boy raised his hand, and he's all happy, he's puffed out. You know how they get happy when they think they got the answer, you know? And you go back and look at it, and I looked on his paper, and on his paper, he wrote ERROR in block letters. That's what the calculator said. Well, gosh darn it, that's the answer. A calculator is a tool. You must teach the kids how to use a calculator. Calculators were really developed for kids that know their basic facts. All right? You ever do a calculator, you do enough problems, eventually, and that answer doesn't make sense. The reason that answer doesn't make sense to us is we know our facts, and therefore we can estimate. Memory is an issue. Maybe memory is an issue for some of us in here, right? But multiple steps. 5th grade is already multiple steps that require all kinds of different things. Get into solving, you know, where 2 lines intersect. Man, there's a lot of steps in that. Memory is an issue. Foundation, talked about that. When we get kids in 6th and 7th grade, if they are missing what I call sort of important skills, they will struggle with what you're teaching, not because necessarily that content, but because they don't have the precursor skills. And that's something that we have to do a better job at filling in when we get to these kids. abstractness, two-column proofs. Does Georgia still do the two-column proofs? I don't know. It was in North Carolina where I taught, they actually, at the end of the course, they had a test that was a two-column proof. That was it, a two-column proof. And then vocabulary. So these, you know, we've talked about these things. Now, specifically to kids with disabilities, now, what's the main difference between a child that has a learning disability and a child that is struggling in math? Anyone? A school psychologist drew a line and said, you're LD, you're not. They have the same deficiencies. But with kids with learning disabilities, it starts early with counting, one-to-one correspondence, counting. Computation in kindergarten and first grade, it's all counting. Count up, count down. They start early, and then it continues. The average 16-year-old maxes out at a 5th grade level in math. And all of you are at 6th grade are going, well, there you go. There you go. 5th grade is when they max out. Major hurdles. Throw in algebra, but you're talking problem solving. Algebra, in my opinion, it's a lot of looking at a problem logically, understanding the math behind it, working through something. And then finally, when they get to high school, they have a lot of difficulties. And as much as reading gets the spotlight, kids that take Algebra 2 successfully are twice as likely to graduate. Algebra 2. Now, I know you don't have Algebra 1, Algebra 2, which is a good thing. When I talk to people from international, they sort of, what is Algebra 1? What is that? What's Algebra 2? What's the difference? Why do you do Algebra 1 and then Geometry, then Algebra 2 Trig? There's no difference. It's math. And that's what Georgia is moving to. So these are the problems. So when you have these kids that are in 6th grade, you know what? I'd hate math too when you get to that point. So building the motivation is something that's very difficult to do. And the best way to build motivation is to put students in a situation where they can be successful. All right. Proficiency. We've sort of been talking about proficiency. What is it? In 2002, the National Research Council came up. These were their 5 benchmarks: understanding mathematics, computing fluently, applying concepts, application, reasoning logically, engaging and communicating with mathematics. These are the main components as outlined by the Research Council that does proficiency. I just got done saying that the National Math Panel basically said exactly the same things, with an emphasis being on these 3 early on so that kids are ready in middle school. So now, the reason I put this up is, in education, what you want to look for is hearing similar messages from multiple sources. Then we start to have sort of some consensus, and that's what we're looking for. Now, who struggles in math? These facts blew me away when I was reading down through these. 78% cannot calculate interest. You know, pair that with what has happened in our economy. There's an argument that, you know what, algebra is important, but how about a whole class on this type of stuff? 71% cannot calculate miles per gallon. Right now it's 100%, and it's not that we can't, it's because we don't want to. 58% can't do a 10% tip, right? 27% of 8th graders cannot shade in a third. 45% cannot solve anything with fractions, all right? Now, dividing fractions, and we're going, well, dividing fractions, all you got to do is this, right? The reciprocal. But, you know, we're at a crisis right here. And these kids moving up are the ones that are going to end up going into these situations. So it's something that's very important. Now, like I said, I sort of threw this up not to beat us up, but just to like, wow, how can that be? I mean, 78% of adults. That means there's some probably teachers, not math teachers, I hope, that you work with that have problems with this. So you see why motivation becomes an issue. Now, time for us to do some math. Now, knowing that you were middle school and high school, I went all the way down to elementary. All right, not to put any pressure on you, but if you don't pass this with a 3 or a 4, you don't get lunch either. We're going to start off with activity number 1, or handout 4 at the top. I'm sorry, handout 3. Handout 3. At the top here, patterns. Math is lots of patterns. I'd like you to go ahead and figure out the answers to the rest of these patterns. I've given you a key at the top. 3 equals 2 pounds. 5 equals 3 pounds. 6 equals a diamond plus 3 pounds. The answers, I've even given you some answers. I don't know what else I need to do here. But go ahead and figure out the rest of these answers. Since everyone seems to have some problems with this elementary patterns, and since we are math teachers, 2 negatives make a positive, right? Yeah. So you may work together with someone.
Then the diamond has to be a 1.
That's what I got with my pattern. Somewhat.
So if a diamond's 1.
Pencils down? Or pens? I'm ashamed, though, that you have pens in this session. This is a math workshop. All right. Now, I know everyone's eagerly working, but I want to sort of move forward here. Here are the answers. Check your paper as I read the answers. 8, 1, 9, 1, 2, 4, 10, 2, 7. Now, did anyone get them all right? No? Make sure I gave you the right answers. 1, 3. Yeah, okay, now. The purpose of this activity was not necessarily for you to get the right answers. I kind of made it a little ambiguous, which, by the way, most math problems are to kids who struggle. But whose responsibility was it to learn this pattern? Ours. As a matter of fact, one could argue that I withheld instruction. I didn't say anything, even though I gave you some cues. But apparently, that wasn't enough for anyone in here. I withheld the instruction. I didn't help. This was a student-centered approach, okay, where I withheld the instruction. Now, all of you like math in here. You were diligently working on it. Some of you are still diligently working on it, okay? Because we like math. You know, right? You go to a lot of kids, they're going to look at this, and what are they going to do? This is stupid. Why are we doing this? Now, maybe some of you are thinking that, but you're all polite. You didn't say it. And now, I left it up to you. I love student-centered activities, discovery learning, I love that. The problem is, or the challenge with that is, you have to have highly motivated kids with a great deal of prior knowledge. Or it becomes a disaster in the making. Kind of like when you don't evacuate from a barrier island in the face of a hurricane. Now, here's how you figure out the pattern. First off, did anyone get some of the answers right? Okay, good, some of you. Now, this is classic with math. Let's think about what we did here. You worked through these problems. You were logically thinking through them in your head. Then I said share. So then how many of you explained to someone sitting beside you how you got your answer? Did any of them immediately say, oh yeah, and erase their answers and put your answers in? Because the LD kid, if you say, are you sure about that? He's going to say, no, it's wrong, and cross it out, whether it's right or wrong. So you went through this. You made this concept or this pattern make sense to whom? You. You then practiced it. Basically, you did what? You learned an erroneous strategy that got you the answer some of the time. So one of the things we know about kids that struggle, if you give them something to do on their own, they will get an answer and they will come up with a strategy. The problem is now you've learned something wrong and it's going to take a long time to unlearn it. Now, the pattern is, because I know everyone's dying to figure out the pattern here, and as math teachers, I have to say this or you will stay working on this. Number one, each pound is an odd multiple. So if we look at 3 in the key, it's 1, 3. If we look at 5, it's 1, 3, 5. Now if we look at 6, start with the pound sign. 1, 3, 5, and the diamond adds 1. So if we look at A, it'd be 1, 3, 5, 7, plus 1, 8. For B, it's just a diamond, therefore it's 1. For C, 1, 3, 5, 7, 9. Now something that was interesting nobody brought up, no one said, can you use the answers more than once? In math class, yes, you can. All right, okay, that was a little difficult. Let's do something easier. Basic facts, flip over. You have 1 minute to answer as many basic facts as you can. Ready, begin. Of course, you have the classic. All right, everybody, pencils down. You have the classic in math class. I'm done and you're not. Right? Now, those of you that spiked your pencil, go back and read the directions. You didn't read the directions? How many times last week did you reprimand kids for not reading the directions? Now, you know, there's a lot of women in here. I don't want this men don't ever read the directions kind of stuff, and we do. Did anyone read the directions? A couple people did. Look, there's like 75 people in here, and 6 of us read the directions. Oh, there we go. LD kids blaming the teacher. All right? I didn't tell you to, okay? Did I tell you to not read the directions?
Just say answer as many basic skills facts as you can.
That's right.
So.
All right, now. That's right. I didn't tell you one way or the other, okay? But here's why did I have you do this? Not to make you not trust me for the rest of the day, but classic example here, and this goes back to what she had said here at table 3. Did how I present that task influence your performance? Absolutely. How the teacher presents content and information is critical for kids that struggle. If you do not do it in a fashion that is systematic and well thought out, your kids, and you all know this, get confused. Then they start applying things that they've heard or bits and pieces of, and it causes problems later on. Now, those of you that read the direction, how many did you finish? How many problems did you get through? 5, 10. So not a lot, but your scores are 1,000 times more than everyone else who did not read the directions. Okay? So again, purpose of this activity was really to sort of hone in on how a teacher presents something. I said, hurry up, do this. You know, you got a minute, as many as you can, and that immediately set things in motion. Immediately set things in motion. The point of that was how you teach a lesson. The language that you use, the examples or non-examples, which are very important in math, when you don't apply a certain rule or procedure, impacts the kids' learning, and that we really have to take a look at how we are delivering the math, okay? Now, ready for another one? I know you're all going to read the directions on this one, all right? Now, this one is to get at sort of multiple steps. Ooh, multiple steps. For the auditory learner in the house, follow the steps, A, B, C, and D, to problems 1, 2, and 3. Now, I'm going to do a quick accommodation. Everybody from table 8 on, so this line right here, you may use a calculator if you have one, okay? No, you cannot move. The rest of you are getting no modifications. I'm not reading it to you. There's no extended test taking time. I'm not writing the answers for you. So go ahead, work on that. Follow the steps. You may count on your fingers if you wish. You know what? You have a calculator. You may use it since you brought it. Your lips are all moving when you're reading. What was the score of that Georgia game? 20, 38, 10? Oh, am I distracting you? 27-10? Okay. There's a lot of laughing going on. I'm glad math is so fun. Okay, you have about another minute on this. That's something you wish you brought a pencil now.
What does C mean? Add this total 10 times. 54th number in the third row. 10 times the number. 10 times this.
Basic computation. Okay, stop. Now, I'll give you the answers. You can do this later on in the evening if you want. The purpose of this was not necessarily, I'm going to force you, teachers, put your pencils down. Look, I know you want these answers. We're math teachers. It kills you to stop a problem halfway. I know that, but I want to move forward here. Now, the reason I did this was basic computation. Would you not agree with me? Some addition, subtraction. But I entered in a couple of other distracting variables. Put your pencil down, table 6. Multiple steps. You had to read. You had to know rows, columns, numbers, operations. Basic operations, all of a sudden in the context of a multiple step problem became what? A little tricky. Now here are the answers for this. 63, problem 1. 98, problem 2. 93, problem 3. Now I took this activity off of Misunderstood Minds PBS website. No, it's not on here. It is, if you Google Misunderstood Minds, it's a really great website with lots of information, reading, writing, math, and attention. I took this off of that website. This here, a basic computation, all of a sudden under a time constraint, with me, I thought someone from table 9 was going to throw something at me because I was purposely doing what?
Sitting here talking, distracting.
Now, it's usually not that overt, but kids that have attention issues, and there's a lot of kids that, you know, at teacher level, standing up, you don't hear things that kids are hearing at the chair level. That can be very, very distracting. And in a multiple step problem, how many of you at one point had to start all over? The rest of you, you're all lying, okay? Now, you all started over. What happens with the kid who struggles? Next problem, and moves right on. So we have to remember we need to build in instructional supports, scaffolds, which I'm going to talk about later, to help kids that, you know what, in math, it's okay for kids only have to do one step. Stop. Talk about that one step for a while, practice that step some more, then move them on to the next step. That's okay. Math teachers, we get into this idea of start to finish. And there's a lot in between that may need some support. Table 6.
I was just going to say that I think that one of the problems that we have across the board is that when a student reads a problem or sees a problem that they consider too hard, they say, forget it. I mean, they literally forget it. And as you were talking about earlier, my gifted students will skip a fraction problem no matter what.
Yeah. And that, you know, I think there's a lot of reasons that go along with why we do that. Part of it is, number one, they know they can. A lot of times, if you can't do the problem, just skip it, you know, and that sort of gets built into that. But you're right, that is a strategy, okay? Kids have strategies. Skipping a problem, waiting for someone to give them the answer is a strategy. It's not a very good strategy. Same thing happens in reading. When a kid doesn't know a word, they just what? Wait till someone tells you or they skip it. So part of it is, especially with older kids, is sort of getting them out of that habit. But the best way to get them out of their habit is to start with problems that they can be successful with. Then get into the more complicated problems. And we're going to talk about that, things you can do for that later on. But that is definitely, kids want to quit. And remember, how many of you wanted to quit? you're all thinking, please let this be the last activity, because I don't want to do it. Now, I took all you really good at math people, and gosh, you don't want to do any more math. Now, that was in 20 minutes. These kids have struggled all their lives, basically. So it's something to keep in mind. You have to build, and with multiple step problems, even though it should be done at once, sometimes we have to break those apart. The other thing that we have to get out in math is sometimes, in order to get the kids to a higher level problem, you have to go back and reteach skills. And today's day and age of moving forward, sometimes it's hard to teach an off-grade level standard. But unfortunately, that's the pre-skill the kids need to move forward. Okay? Now, we're going to do one more quick activity here. Everybody's going, oh my gosh. I took this off the PBS website as well. You must use the addition and multiplication chart at the top of the page. All right? Now, you all know how to use those charts? You find it in the column and the row, and where they intersect is the answer. So you must use those. Now, everybody's going, there's no 11 plus 11. So you use 1 and the 1 to get the answer. I want everyone to use the charts.
Three times 2 is 10.
Okay, I want everyone to go to problem number 8 right now. I just want everyone to go right to problem number 8. I want you to try problem number 8. Now, in that second step there, you have to add, so you have to go to the addition chart.
Oh, my God.
Oh! Okay, stop. I know I'm forcing math teachers to stop solving problems. Now, anyone recognize what the problem is with that? Yes? Base 6. All right? We all learned in base 10. So why did I do base 6? Because it's important to learn base 6? No, because by going to base 6, each and every one of you in here now didn't know their what? Facts. Their facts. How fun was a basic, non-application, generalizable, non-problem solving computation problem when you don't know your facts? I quit. You quit, you hate it, you don't want to do it anymore. Okay? I even gave you a support. You know how common these multiplication charts are in a lot of schools? How many of you liked having to go back up to that chart and then back down and do this? Worse, I've seen the teacher say, if you have a problem with your multiplication facts, there's a chart up on the board. So then you have kids going. All right? This is something that to sort of put you into position. Now, just for a second, imagine that this computation was in the context of a word problem where you first had to apply something. What you have is interference. You are devoting all of your cognitive load to what? Using the chart to get the answer. On top of that, you had interference. What was your interference? Well, yeah, me, but I wasn't on purpose there. The interference was you thought you knew the facts. So that was interfering. I heard some of you say the chart's wrong. Have you ever had a discussion with a child that says, no, my answer's right, yours wrong? Because that's what they're convinced of. So we have to take all of these things into account. That in middle school, we now have groups of kids in high school that simply don't know their facts, get immediately turned off as soon as they see a word problem. Fractions, forget about it. We even have kids that can do a fraction on a calculator to get the right answer. They have absolutely no idea how they got it. They just memorized the procedures. Now, you know, I'm here to say that what we're seeing is there's been a concerted effort the last several years in elementary school to sort of get back to focusing on the foundations of whole number computation, and we're starting to see a lot of progress in both reading and math. Now, eventually those kids will get up to us in middle school, but these are the challenges that you have so that we cannot make assumptions that I'm going to teach this particular concept. The kids have already learned it, that you must possibly do some reteaching or pre-teaching to get the kids to where you want them. Kind of like pay now or pay later. And a lot of us are paying right now with the kids that are coming to us. So now let me give you the answers here so you can go home and work on this. I know you want to. 22, and I'm just going to go from 1 down to 8. 22, 24, 242, 11,502, and I know I'm not reading it in base 6. 13,053. 10. Look how happy she is. She got a computation problem right. 6 is 10, 7 is 104, and 8. Anyone get an answer? 400 is the answer. See, you slowly worked your way up. Our kids that struggle in math would have never gotten past number 3 without causing a problem. All right? Now, those activities, the reason I did these activities was that we as math teachers have to remember the kids that we're working with struggle. Even gifted kids, by the way, they're just as unmotivated as some other kids. The big difference is they eventually get it and they compensate and they move forward. Kids with learning disabilities, at-risk kids, struggle at every aspect. So math textbooks are very unkind and they don't build in enough support. So it's left up for the teachers to sort of move forward. Now we've come to a really good natural break. And what we're going to get into after this break is sort of what we need to do, what an explicit lesson, what are the things that take place in an explicit lesson. Now, what you're going to see is hopefully some of these things you probably are already doing. You didn't realize they were under the umbrella of explicit instruction. A lot of this is just effective instruction. So hopefully some of these things you will say, oh yeah, we're doing that, or we're going to start doing that, sort of as confirmation of what you're doing. And then some other, hopefully you'll leave with some questions of how you can make your math instruction a little bit better. So at this point, we're going to take a 15-minute break, and we'll get started after the break.